Question 2. First of all, before we start question 2, from the review sheet, it's given to you that M equals 8 grams, which equals 0.008 kilograms. And it's also given to you that coefficient of friction mu is 0.2. Okay, now let's do part A. Calculate the magnitude of the normal force on the coin. So first thing you do is draw the force diagram. So there's the coin. Weight of the coin is W there, and normal reaction acts there with the letter R. So in this case, R equals W. That means your R equals mass 0.008 times 9.8, which R equals 0.0784 newtons. That's your answer to part 2A. Question 2, part B. Calculate the magnitude of the friction force acting on a coin as it slides along the wooden surface. Okay, so we know we'll represent friction force as Fr. We know F friction force equals mu times R. So which mu is given to us is 0.2 times R. From the previous part we worked out R was 0.0784, and that gives us 0.01568 rounded to three significant figures, and that would be 0.0157 newtons. And that's your answer to part 2B. Part C. Find the acceleration of a coin moving on the wooden surface. Now at this point you should realize that the only force that's acting on this coin is the friction force going that way, which is friction force, and it's accelerating that way. Stands for A. Okay, so now we know resultant force equals MA. So the only force that's acting on this coin is the friction force, which is acting in opposite to the direction of the motion. So minus Fr equals mass times acceleration. Mass is 0.08 times A. We know the friction force from previous part is minus 0.01568. Write the whole value rather than the rounded one. So 0.008 times A. So A is going to be minus 0.01568 divided by 0.008, and that will give us minus 9. Sorry, that's wrong. That will give us minus 1.96 meters per second square. So that is your answer to part 2C. Right, now 2D, part 1. So 2D says a particular coin travels 50 centimeters on the wooden surface before it comes to rest. Find the initial speed. Now important bit over here is the word comes to rest, which suggests that the final velocity v is 0 meters per second. Okay, and s is 50 centimeters. We have to change it to meters, which is 0.5 meters. And acceleration from the previous part is minus 1.96 meters per second square. So, and we need to work out u. Okay, so which Suvat equation will we use? And that is v square equals u square plus 2as. In the exam, always make sure you sub in all the values first. So 0 equals u square plus 2 times minus 1.96 times 0.5. Plug in all the values in the calculator to get your u, or let's do it algebraically. We'll have 0 equals u square minus 1.96. So u square equals 1.96. So u equals square root of 1.96, which will give us u equals 1.4 meters per second. That is your answer to part D, I. Part D, II, which is second part, says find the time that it takes for the coin to move 50 centimeters. Okay, so now we know from the previous part, we know V equals 0 meters per second, and we worked out U equals 1.4 meters per second, and from previous part we also worked out, we know A is minus 1.96 meters per second square, and we need to work out the time t. Okay, so the equation which we'll use is V equals U plus AT. Sub in the values. 0 equals 1.4 plus minus 1.96 t, and then rearrange to get 1.96 t equals 1.4. So t equals 1.4 divided by 1.96, which equals 0.71428. Write down the whole thing. 57143, and then round it to three significant figures, which will give us t equals 0.714 seconds. And that is your answer to part D, II, and we are done with question 2.